We are going to move on to a little bit more sophisticated things here. The measurement likelihood and the Bayesian inferences. And afterwards, we'll have some computer simulation to show you some of the power among the different methods. So just kind of give you some idea. But for these two methods, it requires some concepts on statistics. This part is most difficult for most of the students. So we'll see if we can get through it easily. The basic idea we want to resolve is to find the best tree to resolve the relationship for whatever it is. So for example, here we got the relationship among human, gorilla, and chimpanzee. And there, if we use orangutan as an outgroup, there are only 3 different hypotheses. So in this simple example, of course, we can try to calculate the probability of the tree, which one has the highest probability to be the best tree. Or we can also use the likelihood value and put onto the different trees and to see which one has the highest likelihood value of it. Anyway, so different ways to evaluate the trees is just trying to get what is the most possible trees or the best tree. And likelihood and the Bayesian inferences are kind of 2 ways and 2 different ways to solve the problem. And actually, those kind of 2 schools in statistics, and sometimes they don't like each other sometimes. And so these different ways of solving things are based on a different thinking. And we'll start from the likelihood later on, and we'll keep going on for the probability. For the maximum likelihood school, the people want to solve the problem is which one is the better one. So this one or that one or that one. So one way is to calculate a likelihood value of the particular tree, then compare the 2 trees. If it has a higher likelihood value, then that one is better. And how to compare the 2 different trees? We can use this kind of the formula to try to solve this problem. And for statistics, you can compare the 2 different hypotheses in this way. So the probability of hypothesis 1 given the data, and we'll worry about that later. And that is basically the Bayesian theorem. Want to estimate the prior probability and then try to recalculate the ratio. And the other ways, like the maximum likelihood score, they want to compare the actual probability of the data given a particular hypothesis, 1 or 2, and try to compare those 2. And also we have a very special ratio, that's the prior probabilities, and sometimes it's hard to estimate. But anyway, this part is more concerned by the maximum likelihood score, and this part is more concerned by the Bayesian score people. And this is called a conditional probability. Well, if you don't know the statistics so far, but we'll go to the actual calculation later.